All right, in this video, what we're going to learn is how to write a mathematical model to describe a constant motion graph. And what does the y-intercept mean? So that's what we're going to talk about today. So let's jump into it. All right, we have a position time graph here. A constant motion graph is a linear line. You should have seen this in a lab already. And if it's a linear line, that means it can be modeled using a slope-intercept equation. So you should remember this or jog some foggy memories from algebra. That slope-intercept equation is y equals mx plus b, where m is the slope and b is the y-intercept. So let's apply this equation to the graph that we have. So you can find the slope by, since you have a graph, you can find the slope just by rising and running. So we see that in this graph, the slope is a positive 4 meters per second because you rose 4 meters from 4 to 8 and you ran 1 second. One thing to avoid is you might say, oh, well, I only rose 2 because I rose 2 blocks. But if you look at the scale of the graph, it's going up by 2s. So if you go from 4 to 8, you've actually had a rise of 4 meters and a run of, in this scale, 1 second. And the slope is positive. It's going up and to the right, so it's a positive 4 meters per second. The y-intercept, well, that's 0 because at time 0, where does this function intersect the y-axis? It intersects the y-axis at a position of 0 meters. So that's the y-intercept. And something to note here, if you look at the units of meters, that is a unit for position. And so the y-intercept is actually representing the starting position on a position time graph. So if this is the slope and this is the y-intercept, you can plug that into your generic math model. So y equals 4x. You could write plus 0, but you don't need to write it because it doesn't exist. The thing is, a generic math model usually works in math class. In science, however, every graph has a physical meaning. So this is a position time graph. We need to express this generic math equation in physical terms. And so I'm going to take that y equals positive 4x that we would see in math class, and I'm going to translate it. Well, we know on this graph that the y-axis is position. So instead of writing y, I write position. We know that the x-axis is time. So instead of writing x, I write time. Also for the slope, instead of writing a number with no units, I'm going to write units with it, meters per second, because that slope has a physical meaning. It means that if I want to, this equation means that if I want to determine the position of this object, I can multiply a velocity of 4 meters per second times the time. So if I'm at time 2, 4 times 2 would be 8 meters. So at time 2, I go up here and I see, hey, that's at 8 meters. So I've created a mathematical model that is translated into physical terms. All right, so let's go through the rest more quickly. Same analysis. Constant motion graph, linear line. You notice, though, that this graph is starting in a different position. So let's get our information here. We have a slope of positive 2 meters per second. Go from 0 to 2 and run 1. And we have a y-intercept. This function intercepts the y-axis at -6. So the y-intercept is -6 meters. That means that the starting position of this object, on this represented by this graph, is -6 meters. Plug that into our generic math model. Y equals positive 2x minus 6. And now translate. Instead of y, put position. Instead of x, put time, and add units. Let's plug in a sample time. I didn't write this down, but we can talk it through. If my time is 5 seconds, 5 times 2 is 10, minus 6 gives me a position of 4. So at 5 seconds, I should expect a position of 4. And I look over here, and that's what I have. If my time is 0, 0 times 2 is 0. This goes away. My position would be negative 6. At time 0, my position is negative 6. So the equation works, and it's written in physical terms. And finally, one last graph, linear line, constant motion. We go to the slope-intercept equation. This function is moving down and to the right, so it's a negative slope. So we go from 7 to 6 meters. So a rise of -1 and a run of +1 gives you a -1 slope. And you see that the function intersects the y-axis at a position of 8 meters. So that's the y-intercept, the starting position. We get our generic math model of -1x plus 8, and we translate. So at time equals 1 second, 1 times -1 is -1. -1 plus 8 is 7. So at 1 second, we would expect that the position would be 7, and it works out. That's all for today. I will say, though, that this video is very important because in your labs, whenever you have a linear relationship, we will be asking you to create the math model using y equals mx plus b, but to express it in physical terms like you see here. For this unit, that definitely means using position and time. And for other units, the physical terms will be different. Thank you.